Okay, what we didn't get to in that first section of this video was about the composition of functions. And composition of functions is putting functions together, but in a slightly different way than what we showed you above. And we're putting these functions together. What we're going to do is we're going to insert a function in for x of the other function. So basically, A here says f of g of x is how it's read, and just how it said here, f of g of x. And how this is similar is just saying, well, I typically have a function f of x, and what it's saying is we have another function g of x, and what we're going to do is anywhere we see an x in f of x, we're going to plug in g of x's function. Just the same way if I had f of 2, right, I would have plugged 2 in anywhere I saw an x, because f over here is on the outside, the function. So it's saying the function, what's the function worth, or what is the function when we plug in the other function? We plug in g of x. Just like saying, what is this function over here? What is that thing worth, or what's its value when I plug 2 into that function? And kind of vice versa here in B, it's saying, all right, now I'm going to take, it's saying g of f of x. All right, so now it's saying, what is the value of the function g of x when I plug in f of x function? And you'll see more as I do an example. It'll make sense to you here. Make more sense as I'm going on here. All right, so example 1. If f of x equals x plus 1 and g of x equals 1 all over x minus 1, find f of g of x. Okay, so I have it written this way. Some people like f of g of x better, all right? Because that kind of tells you that anywhere I see an x in f of x, I'm going to plug in g of x's function. So I'm going to plug this in anywhere I see an x in f of x. So I see an x here. So it's going to be 1 all over x minus 1 plus 1. All right, then we can do some simplifying. Remember to combine these. Common denominator would say we could have a common denominator of x minus 1, because I multiply the top and the bottom by x minus 1 to get a common denominator. And then I can combine like terms, right? I can combine this 1 and this x, and I can have x all over x minus 1. And that's all we have there. So that would be f of g of x. Would be x divided by x minus 1. If I wanted to do g of, it's not asking us to do this, but if I wanted to do g of f of x, so it's saying what's the value of the g function g when I plug in f of x? I would say, okay, 1 divided by, where I see an x, I'm plugging in the f of x function. So I'm plugging in x plus 1 minus 1. Because where this x was, I'm plugging x plus 1 in for the x right there. And then you write everything else the same. So I could simplify it, 1 all over x. And that's it right there. Okay? So continuing on here. If f of x equals x squared minus 1 and g of x equals 3x, find f of g of x. Again, like we're saying, we're going to take g of x, and we're going to plug it in anywhere we see an x into f of x's function. So we're going to go ahead and we're going to plug it in here. So we're going to get 3x squared minus 1. Now we square 3x, we get 9x squared minus 1, and that's it. If they're asking us to find g of f of x, like that, we would plug in f of x anywhere we see an x in the g function. So I would have 3 times x squared minus 1. 3x squared minus 3. And that's it. One thing that comes out of this, it says if we're given two functions, we can tell if they're inverses of each other. If and only if we do f of x and g of x, if both of those equal x. So we plug the g function into f and we get x, and then we plug the f function into g and we get x, and then they're going to be inverses of each other. And if we're just asked to find the inverse of a function, all we have to do is switch the x's and the y's and solve for y again. So for x to find the inverse, we can just switch the x's and the y's. So here we go. It says, example 4, given f of x equals 4x minus 9, find f prime of x, which means f prime of x, or sorry, not f prime of x, f to the negative 1 power, f inverse of x, and show that f and f inverse are inverse functions. Okay? So to show that they're functions, we're going to show that f of g of x equals g of f of x. But anyway, first off, we want to find the inverse of something. We switch our x's and our y's. To find the inverse, we switch the x's and y's. So x equals 4y minus 9. I change this to a y, change this to an x. You switch the x's and y's, that means inverse. Solve for y again, so we're going to add 9. X plus 9 equals 4y. All right, so we get y equals, divide by 4, x plus 9 divided by 4. Okay, so that would be your inverse, denoted by f of negative 1, so f inverse equals x plus 9 over 4. To show that they're inverses of each other, all we have to do then is do f of g of x and g of f of x. So here's my f of x. In this term, let's say my g of x is my inverse. So it'd be x plus 9 divided by 4. So let's do f of x. Of g of x. All right, let's do that. Let's see what it equals. All right, so anywhere I see an x, I'm going to plug in x plus 9 over 4. So 4 times x plus 9 over 4 minus 9. Look diagonal and cross out, it's easy enough. X plus 9 minus 9. Subtract those and we get x. All right, so f of g of x equaled x. That was part of that theorem that we had up there. The next thing we needed to check is, does g of f of x, does that equal x? If they both equal x, then they're inverses of each other. Okay, so now anywhere I see an x, I'm going to plug in 4x minus 9 and for x up here. So 4x minus 9 plus 9 divided by 4. Well, minus 9 plus 9, that's 0, right? Then I have 4x divided by 4. The 4's cancel out. I'm left over with x. So that last theorem was saying, well, if we do f of g of x and we do g of f of x, and they both equal x by themselves, when we do both of those two are inverses of each other. So it's a way of checking ourselves. All right, so they're inverse of each other. Go ahead and hit the pause on that and try that by yourself. Remember, to find the inverse, you just switch your x's and your y's. All right, and then go ahead and show that they're inverses of each other by doing f of g of x and g of f of x, and make sure they both equal x. If they both equal x, it's an inverse. If they don't, they're not inverses. Last example real quick. Given f of x equals x squared minus 1, find the inverse. All right, so again, we switch the x's and the y's. So x equals y squared minus 1. I'm going to add 1. We're going to solve for y again. So x plus 1 equals y squared. And then in order to get y by itself, we're going to take the square root of both sides. The square root of both sides, so y equals, anytime we take the square root, it's plus or minus the square root of x plus 1. Okay. And those would be inverses. Okay, I hope this helps. We'll see you in class.